So first, today we are going to learn the Cauchy's mean value theorem for two functions. Okay, if two functions are there with us, whether it is done with the two functions. So what they are saying it as that if fx and gx be two functions defined in a closed interval ab, where ab and any two constant quantities. Number one, following the satisfying the following conditions. What the conditions are? First one is fx and gx must be continuous in open interval ab. Sorry. Second one is fx and gx are derivable, continuous in closed interval ab and derivable in open interval ab. Okay. And third one, which is not not a condition, it should be true always, with g dash x must not be equal to 0. Because in our expression, g dash x will be in the denominator and that must not be equal to 0. Otherwise, it does not make any sense. Okay. So if these conditions are satisfied for these two functions fx and gx, then there exists at least one value c, obviously somewhere lying between a and b, such that fb minus fa divided by gb minus ga equals to f dash c divided by g dash c. So c will be obtained from this relation utilizing this equation. Okay. Now next is what, as we have seen in LMVT, that is Lagrange's mean value theorem, the h theta form. It is nothing but the interval in the interval AB. If B is replaced by A plus H, then the point C, which is somewhere between A and B, can be written as A plus theta H, obviously where theta lies between 0 and 1. So if this be the modification, then CMVT, that is Cauchy's mean value theorem, takes the form FB becomes FA plus H minus FA, GB becomes GA plus H minus GA. And if dash C since C is a point now A plus theta H, so it becomes F dash A plus theta H divided by G dash A plus theta H. All right. So this is the form of CMVT as well as the modified one, that is H theta form of CMVT, right? Now let us go. Is it the picture of CMVT in both in its the interval AB form and the H theta form? Is it clear now?
Yes, ma'am.
Okay.
Yes, ma'am.
Okay. So next, we can take on a particular problem. This one is A01. Look at this problem. Apply CMVT to the function fx equals to e to the power of x and gx equals to e to the power of minus x. Again in the interval AB. Prove that C belongs to AB. That means C, which is lying somewhere between A and B, is having a value which is the arithmetic mean of A and B. Okay, so let us go to the whiteboard to do the problem. What the problem is, we have the two functions fx and gx. Fx and gx are two functions. What is our fx? Fx is given to us as e to the power of x. And another function is there gx, which is given to us as e to the power of minus x. All right. What we require to prove that, using CMVT, that is Cauchy's mean value theorem, we need to prove the value C, which belongs to AB, belongs to open interval AB, means it lies somewhere in between A and B. That value C is equals to what? Arithmetic mean of A and B. That means C must be equals to how much? What we require to prove?
A plus B by 2.
Yes, C must be equals to A plus B by 2. So we are going to find out the value of C and we can see that C becomes A plus B by 2. So let us find out. First, we need to utilize the conditions of CMVT. Unless the conditions are satisfied, we cannot find or we cannot get the point C according to the statement of the CMVT Cauchy's mean value theorem. what the first condition is? Fx and gx both must be continuous. Obviously, in open interval AB, fx and gx will be continuous. In closed interval AB, fx and gx is continuous. Why? If you can tell me. The function whichever is given to you as fx and gx, they are actually always continuous. Can you tell me why? Sorry.
Because
Because
exponential
Yes.
functions
They
and
were equal to
trigonometric
0.
functions are
yes,
continuous in all intervals.
yes. So exponential functions are always continuous. All we know that logarithmic functions, exponential functions, trigonometric functions, they are all continuous functions. Okay. So since both are exponential functions, so they are continuous. Similarly, the derivative exists in the interval AB, because derivative of e to the power of x is e to the power of x itself, and g to the power of x is minus e to the power of minus x itself. So in the interval AB, where a and b are both finite constant quantities, this must be derivable or else you can say derivative must be exist. Okay. Now we can find C. Now how C will be obtained? C belongs to open interval AB such that what the condition we will be having? If B minus FA divided by GB minus GA equals to F dash C by G dash C. So let us now just replace the values in the expression. This relation FB is what? If Fx is e to the power of x, FB is e to the power of B minus Fa is e to the power of A divided by GB is e to the power of minus B minus GA e to the power of minus A equals to F dash C. What is F dash X? F dash X is e to the power of X. So it is e to the power of C. G dash C minus e to the power of minus C. Now just simplify to get the value of C. Let us see what happens. It becomes e to the power of B minus e to the power of A. Numerator remains as it is, and the denominator I am writing it as 1 by e to the power of B minus 1 by e to the power of A. And the right hand side becomes negative sign will be there. E to the power of minus C will go up. So it becomes e to the power of twice C. Minus C becomes plus C. C plus C is twice C. Now from here, what will I do? From the denominator, I will take the LCM e to the power of B into e to the power of A. Numerator, let us remain as it is, e to the power of B minus e to the power of A. In the denominator, we are taking it LCM as e to the power of A into e to the power of B. And after taking LCM, it becomes e to the power of A minus e to the power of B. Right hand side remains as it is, minus e to the power of twice C. All right. Now just simplifying this, e to the power of numerator is e to the power of B minus e to the power of A. Denominator becomes e to the, if I take negative sign common, then e to the power of B minus e to the power of A, and e to the power of B into e to the power of A. That becomes e to the power of A
plus B.
and it will go upwards in the numerator. Okay. And equals to the right hand side remains as it is, minus e to the power of twice C. So now it becomes what? This get cancelled. Negative sign is there. So negative sign cancel from both sides. So we will be having e to the power of A plus B equals to e to the power of twice C. So since the bases are same, exponent should also be equal. So what we will write? Base same, exponent equal.
Equals to A plus B by 2.
B equals to T.
A plus B equals to twice C. So equating the exponent A plus B equals to twice C, or else we can write it as C equals to A plus B by 2, right? So it becomes arithmetic mean between A and B. In this way, the value of C as we are required to prove is A plus B by 2. So the next problem, what it says to us, problem number 2, that if again the functions we have taken, f(x) equals to e to the power of x and gx equals to e to the power of minus x. These are the functions. Now they are saying that theta lies between 0 and 1, or x lies between c, which is lying between a and b, is independent, or theta is independent. What the problem? Let me go to the problem once more. I forgot. Yes, that prove that theta is independent of both x and h. So theta I need to consider over there. Okay, fine. So we require to prove here, according to our problem, this is our given part, and we need to prove that theta is independent of x and h both, right? So since we are discussing over here theta, h, all these things, that means obviously I need to take the h theta form of CMVT. H theta form of CMVT. As we have seen from the earlier that fx and gx, whichever the function is given to us, it satisfies the conditions of CMVT. So according to H theta form, what will I write? If a plus h, or you can take it as fx plus h, as they have told you to take it as x and h, whatever, minus fx divided by gx plus h minus gx is equals to f dash x plus theta h, yes, divided by g dash x plus theta h. So this is the form that we are going to utilize to get the value of theta. Here I need to get the value of theta, and we are going to see, or we are going to prove that it is independent of x and h. So let us move on by putting the values of the functions. If x plus h means e to the power of x plus h minus fx e to the power of x divided by gx plus h means e to the power of minus x plus h minus e to the power of minus x. Next is what? Equals to f dash x is e to the power of x. So it is e to the power of x plus theta h. G dash x is minus e to the power of minus x. So minus e to the power of minus x plus theta h. All right. So let's simplify as we have done for the previous one also. The numerator remains as it is, e to the power of x plus h minus e to the power of x. The denominator, I will take it as 1 by e to the power of x plus h minus 1 by e to the power of x. And the right hand side will be with a negative sign, e to the power of, it will go to the upward side, and we will be having it as e to the power of twice x plus theta h. All right. Now simplify once more. Numerator is x e to the power of x plus h minus e to the power of x.
Then theta came half.
Yes. Huh? Yes, theta will be
Theta.
half. Okay.
Yes,
So,
ma'am.
and the denominator, if I take the LCM, e to the power of x plus h into e to the power of x will come out in the numerator, and denominator becomes e to the power of x minus e to the power of x plus h. Right hand side remains as it is, minus e to the power of twice x plus theta h. Similarly, now after this and this will cancel with a negative sign coming out. Okay. So we are left with minus e to the power of x plus h into e to the power of x equals to minus of e to the power of twice x plus theta h. So again the exponent is same because we can write it as minus e to the power of twice x plus h equals to minus e to the power of twice x plus 2 theta h. So after cancelling out the common parts or equating this exponent, what we will be having? Twice x plus h equals to twice x plus 2 theta h. This signifies what? 2x get cancelled. Then theta equals to h will also be cancelled. Theta equals to half. Okay, so it is independent of x, it is independent of h, it is having a numeric value that is equals to half. That's why theta is independent of both x and h and the value is equals to half. All right.